This conference will now be recorded.
So very good evening, students. We have been discussing statics chapter. In fact, we are revising various previous year's questions from JEE main especially. So today we'll be solving some problems related to that. So let's start our discussions today. Okay, so today's first question is this one. As you see in the figure, this is charge versus voltage or potential difference of a parallel plate capacitors. So figure shows Q versus voltage graph for, oh, this is for. So this is for series and parallel combinations of two given capacitors. So two given capacitors, C1 suppose and C2. Okay. So when they are connected in series, the charge stored in the capacitor, combination of the capacitors is plotted against the voltage. Okay. And charge stored in the parallel combination of the capacitor also has been plotted against voltage. So this is the again graph where A and B, these two graphs are showing the charge stored either in series and parallel combination of the capacitors C1 and C2. We have to first so the question is you have to find out what are values of C1 and C2. Values of this. You have to find out that. So first of all, we have to recall when two capacitors are connected in series or parallel, what is the equivalent capacitance? The case of series combination, we know it will be just like parallel combination of resistors. In case resistors, so C equivalent will be multiplication by addition of this, right? And for this case, it will be C1 plus C2, isn't it? So can you tell me for which the charge stored? See, they are actually connected both with the same voltage, same voltage source, or with the same battery. Then which among these two combinations, one is parallel combination, another one is series combination, which among these combinations will store more charges? Obviously the parallel combination, because we know charge stored will be q is equal to cv. That means q is directly proportional to c. So if the capacitance is more, then capacity of holding charge also will be more. Therefore this graph A is definitely for parallel combination. Parallel combination. Okay. So what does this see? You know, this charge is equal to C into V. So if we plot Q versus V, the slope dq by dV or for a linear graph Q by V, this is the slope which gives you the capacitance. Okay, so if we take the slope of each curve, so this is actually for series combination. This is very clear, I hope. Series combination. I'll just erase this part so that I can use for calculation. So the point is that the charge stored in capacitor is directly proportional to the capacitance of the capacitor. So in case of parallel, equivalent is C1 plus C2. So the charge stored by parallel combination will be greater than series combination. Okay, that is what we understood. And then we have got the idea that this is for parallel capacitor, this is for like parallel combination of the capacitors, and this is for series combination of the capacitor. Now one more thing, see, we know Q is equal to CV, which I was telling you now. So Q is equal to CV. That means if we plot Q versus V, then slope of the curve, it is a straight line, we can write Q by V. That will give you C. C is the capacitance of the combination. So look from here, from this graph, what I can write. Again, I'll just erase this part. See, for the graph A parallel combination, what is the equivalent capacitance? Cp is equal to C1 plus C2. I'm writing Cp and Cs. P is equal to C1 plus C2. That is equal to Y by X. Y is 500 by 10. This is actually in microcoulomb. This is in volt, so it will be in microfarad. Okay. So what we'll get? So we have got C1 plus C2 is equal to 50 microfarad. Okay, so that is what we have got now. Sorry. What we have got? 50 microfarad. Okay. Now look this curve B. So from here, what we will get? CS means C1 C2 divided by C1 plus C2. So this I'll get from the slope. So Y by X, Y is 80, X 10. So we get 8 microfarad. CS is equal to, right? Look, then I get C1, C2. I have to just solve for C1 and C2. That is the question. So I have got two equations and there are two unknown terms, C1 and C2. We have to solve for C1 and C2. So we get C1 into C2 divided by C1 plus C2 is equal to 8 microfarad. So this C1 plus C2 we have got from here 50, right? So I can just multiply here. C1, this is C1 plus C2, which is given as 50 microfarad. I'm just writing it here. So this is 50 and microfarad square. Okay. So from here we are getting C1 and C2. Okay, I'm just erasing this part and writing it directly. So C1 and C2 we have as 400 microfarad square. Okay. Now look, we have C1 plus C2 here. See, let us write this as equation 2 and this as equation 1. Okay, so from equation 1, what we are getting? C1 is equal to 50 minus C2. All right, 50 minus C2. Now if we multiply it here, see C1 and C2, what we are going to get? Eliminating C1 by doing this. So this is 3, this and 3. So from 2 and 3, what we get? C1 is 50 minus C2 into C2, that is equal to 400. Okay, now if we just multiply this, we can just get a quadratic equation. See, 50 C2 square, and here it is 400. Then look what we are getting. We are getting a equation. I'll write this quadratic equation. Let me write it here somewhere. I'll just erase this part. So we have got a quadratic equation. We have to solve this to get C2. So look, we'll just take it all in the same side. So C2 square minus this is 50 C2, and this is to this. Oh, I'm sorry, this is plus itself, because we are taking this on the right hand side. So we can use uh, so let us see, C2 will be minus B. This is B with a minus sign, so this is plus square root B square, that means 50 square minus 4AC. 4 A means 1 into C, this 400. Okay, 400 divided by 2 into A means 1. Okay, so if we solve, what we get? Plus this, plus or minus this, and look, this will be so this, I'll just erase this part. So this is going to give you plus or minus this. This will be giving you 900. Square root of 900 means 3 and 10, right? 30. So this is 30 divided by 2. Okay, so if I just divide with 2, we'll get 25 plus or minus 15. Now this can be plus or minus. Okay, so if we take plus, that is 40, that will give you 40, right? And if it is minus, see, we'll just do one thing, make it plus, so it will be actually either 40 or it will be 10. Okay, so there are two possible values for C2. Now we have to judiciously find whether it will be 40 or 10. Okay, so we'll just first can try to analyze whether it is plus or minus, and that can be even done after calculating the other one also. Okay, so let us go for calculating. So we have got the value of C2. We are just erasing this part. We'll write here. This calculation part I am removing. You might be smart to do this. Just look the process. Okay. I'm just writing just here. C2 is equal to either 14 or 10 microfarad. Okay. Now look, I am here. If I have got C2, then what is C1? C1 is C50 minus. If I write it 10, it gives you 40 microfarad. Okay, 40 micro. If I write C2 as 40, then it would give you 10 microfarad. Okay, so look, if you take 40 over here, you have to take 10 over here. If you take 10 over here, then you have to take 40 over here. So look, what are the options? So if either of them 40, then the other one must be 10 microfarad. That is inference we can get. Take 40, then we get 10 microfarad. If we take 10 here, then 40 microfarad. Okay. So anyway, these two are either 40, like C1 is either 40 or 10. Similar possibility is there in this case. But anyway, the values are 40 and 10. But look there here, 40, 60, 30, 50, 20, 30. So there is no problem to choose this, right? So the option D will be the correct answer for this. Okay. I hope you have got this. This is very simple. Just a little bit of calculations. Otherwise, nothing. Okay. Now let us go to the next problem. This problem is really a very, very interesting problem. Okay. I think, okay, let me get the necessary figure here. Figure for the problem is this one. I forgot to put it in the PPT. Anyway, let me read the problem out first. Okay, so this problem states that a parallel plate capacitor is made of two square of side A. So there are two square plates, like see, this is a parallel plate capacitor. So kind of this. Okay. Oh, in fact, yeah, kind of this. Two square plates up parallelly situated, as you know, to make a parallel plate capacitor like this. And see, the sides of all, see, this side, these are actually A, as you see from here in the figure. So sides are A, separated by a distance D, and here the separation is much less than A. Okay, A is the length of the sides of the square plates, and D is the separation, or we can say the thickness of the medium inside the plates. Okay, so two lower triangular portion is filled with a dielectric constant. Not two, the lower triangular portion. So look, this is the triangular portion. As you see, the shaded region in a triangular shape, there is a dielectric material of dielectric constant K is inserted. Okay, inserted. So what will be the capacitance of this capacitor? Very interesting and important problem. Look here. I'll just explain the problems once again. There is a parallel plate capacitor simply, which has, so this is the length of the parallel plate capacitor, and this is the separation between the plates, and separation between the plates is much less than the length. That means ideally the triangular portion filled with a dielectric constant, dielectric material of constant K. Now you have to find out the capacitance for this capacitor. Okay, so it is very simple if we understand the problem. Look here, actually when this problem itself we do with this, suppose there are two separate dielectric material of thickness K1 and like having dielectric constant K1 and K2 and having thickness T1 and T2. Then what do we do? And suppose this is the whole D, or maybe let me write, yes, this is the case. If this is the case, then what we do to find out parallel capacitance? See, the formula for this actually, epsilon 0, the area, suppose area, epsilon 0 A by D, in place of D, and obviously there will be, okay, so since this is having different thickness, so what we do, in place of D, what we write? See, we write T1 by K1. If you remember, T1 by K1 plus T2 by K2. This would give you the capacitance of the capacitor in this kind of cases. So if look, this is, okay, so this is the formula if you remember. Now if suppose this thickness is D and T1 is filled with some dielectric material K, and this is with air, then what you do? In that case also, nothing to worry, we can use this formula itself, epsilon 0 by A, and in this case D minus T1 by K we have to write. Okay, so that's the thing here. All right, so what we can do is we can actually see, since it is parallel, actually there is a uniform thickness, but here the thickness is not uniform. So in these cases, so what we need to do in these cases, what we need to do is we need to actually do in a different way. We cannot directly write the formula. Let us just consider a rectangular strip over here, as you can see, rectangular strip. Okay, all right, so this is a rectangular strip which has length is D and thickness is dx. And let us say from this left hand side, we are just from left hand side, it is at x distance away, and this has a thickness dx. Okay, dx. All right, and this has length, anyway this is d total length, but let us say up to this, from the base to, from this plate to up to this, let us say this thickness is y. I hope you are understanding what I'm writing over here. Let me write it here. So this is y, suppose. Okay, see what I have done. I'm just drawing here itself. Okay, so this is the case. So I'm just drawing a strip over here, rectangular strip from the left at a distance x. This has thickness dx. Okay, and see from here to here I'm taking this distance as y. Okay, this is y. All right, let me. Okay, this is a y. Now see what we can do. We can actually use the properties of similar triangle. Then by doing that, what we can write. So this is y by x. We can write y by x is equal to. So this is d and this is a, right? So d by a. So this is what we can write. So from here, what else we can do? We can find out what is y. Y, or if you want to find out x, you can find out x also. Let me write what is y. Y is d by a into x. So this thing we will write down and keep d by a is equal to sorry, y is equal to d by a into x. I hope you have understood this. This is from the properties of similar triangle, and I'm just erasing this just to do the calculation over here. And look, this is the figure now. So this is having x distance away. So y by x is equal to uh, d by a. So from there I can write y is equal to what? Okay. So if we require, then we can find out dy also. Dy will be d by a into x. See here actually this thickness is actually changing, right? Thickness is changing. This height is changing. At each position this y is changing. That's why this is a variable quantity. So what we can do actually, we can just do integration. Okay. First of all, let me get the capacitance for this also. So the total capacitance for this strip, this rectangular stripe. Okay. So what will be that? So let us say that is dc. That means a small element I have taken. So small element will have small capacitance, that is dc. So we can write down the formula epsilon naught a. A means area. What is the area of this? See, area will be, since this is dx, okay, so this is dx, x dx, and this is yeah. So area is dx into this okay, so this is d, just a minute. This is the area will be dx into d, or a dx. Okay, so this area will be actually a dx. Now this is so epsilon naught into a divided by, as I said, this part will be, see, d minus of y, this part having dielectric constant of 1 plus this is this part actually having thickness y and dielectric constant k, so we will write y by k. Okay, y by k. Y by k. Okay, so this is the capacitance for this whole strip. Okay, now if we want to get the capacitance for the whole thing, then what we have to do, we can just actually add this stripes. Okay, capacitance for this identical stripes. Okay, and if this thickness dx goes to, like, limit goes to 0, then we can just convert this into integration. Okay, so we can just do the integration over here. Okay, and integration on dx. Okay, so integration will be on dx. Here this is not d, this is not the thickness d, this is dx, a into dx. Okay, actually this, you might be thinking why this area is a dx. Let me write. See, this much is the, if this much you think y into dx, right? So this much is y into dx. You can write from here y is equal to d by a into x. Anyway, so the area will be a into dx. All right, so look here. Here we have integration on dx, and see, dx goes from 0 to a. This goes from 0 to a limit. And what is this y? We have to put the value of y from here. So we can put the value. Okay, let me just keep this part, this the minus y, this one. Let me write in the next epsilon 0 a, let them be out of the integration because they are constant. So dx by, the limit goes from 0 to a, and this is d minus, let us take common y common from here, so minus 1. So here it will be plus 1 minus 1 by k. Okay, now put the value of y from here, d by a into x. So if we put the value of that, epsilon 0 a 0 to a dx divided by d minus y is d by a 1 minus 1 by k into x. Okay, then we can do the integration part of this. So integration, will just take this like dx divided by d minus d by a 1 minus 1 by k. So this is a total constant, and this is x. Okay, now see, we can actually do the integration 0 to a. It will be actually 1 by x, see this you can just treat as x, so 1 by x means ln x. Ln x, look here, ln x is the whole part, whole term, d by a, 1 minus 1 by k, okay, ln of this. And see, since it is not exactly x, so there will be multiplication term minus d by a into 1 minus 1 over k. So this is the term. Now if you put the proper limit, then you get the total C. You just go and put the limit. I'm just writing over here what is the actual. See, if I just write here, put the limit of x 0 to a, okay, so a get cancelled from here. So anyway, so if you just put it here again back, so you will get total capacitance epsilon 0 a. In fact, there will be another a from here, so this will be a square k divided by d into k minus 1 and ln k, because if you put it x over here, so it will, so this will be d and d will get cancelled by each other, and then you will get ln k. Okay, so this is the capacitance, capacitance of the capacitor. We'll look for the answer. So it is here, k epsilon 0 a square ln k divided by d into k minus 1. So this is the answer. Okay, so we'll go to the next problem. This is also a very interesting problem and very important problem. So let us first understand the problem itself before we solve. So what is this problem saying? Let a total charge 2q, let a total charge 2q be distributed over a sphere, be distributed over a sphere of radius r. That means, you know, suppose there is a sphere of radius, sorry, this is suppose a sphere, roughly a sphere of capital radius capital R. 2q charge is just given to this and it is distributed over the sphere with charge density rho r is k of r. What does this mean? Charge density rho r is equal to k into r. That means, see, this 2q charge has been distributed within the sphere. This is a solid sphere, and the charge density at each point, it is not uniform, it is varying with this. Okay, that means charge density is varying like this. If you go with distance, it is varying like that. Okay, as you go outer and outer, you will get more and more charge, and interior there will be lesser and lesser charge. Anyway, so 2q is distributed over this sphere, but the charge density is not uniform. That information is here. Now two charges A and B of minus q each are placed diametrically opposite points at equal distance from the center. Okay, so it is, I think, distance a. This is not from, this is from the center, from the center. Okay, if a and b do not experience any force, then what is the value of a? You have to find out. Look, let me tell you the last part of the problem. The last part says that suppose this point is a and this point is b. They're at equal distance from the center. This is center. Okay, from the center they are equal distance a, and both are actually minus q. Okay, minus q. Charges are there at this place and this place, so they will actually repel each other, right? They will repel each other. So this is a b a. I'm sorry, this is a on a, force on a. So at this position, force on a due to b will be in this direction, repulsion, and force on b due to a also will be there at this position, and that is, since it is repulsion, it will be pushing it out. This force will be pushing the a out. So there will be a repulsive force between them. But the question is that there are charges here also, right? Inside this there is charge. At each and every point the charge is varying like this. Okay, so when these two charges don't feel any repulsion or no force at all, they don't feel any force, don't experience any force, then what is the value of a? So here the clue point is, or key point is that the repulsive force magnitude of the repulsive force must be this repulsive force must be attractive force. See, there are charges, right? So those charges will be actually, if I just consider this as a sphere, suppose a small sphere which has charge density varying as kr. Okay, this is having, suppose, radius a. Okay, this is a small sphere having radius a. So it will have actually an electric field here and here. That electric field actually will be attracting each other. So the electric field is always uh, radially outward. Okay, radially outward. But these charges are minus q, so they will be actually pushed inward. Both of them will be pushed inward because of the electric field produced by the charge held within this small sphere. I hope you are understanding it. Attractive force by the field produced at a or b, not or, and. So both of them will be actually attracted towards the center due to the field produced by the charge contained in the small sphere of radius a. Okay, we know we can find out the repulsive force. What is the repulsive force on each other? So both of them are having the same charges. So q1, q2. Okay, so q square, it will be, if I take the magnitude, q square by, like, kq square by 2a square. Okay, that is the repulsive force between them. And what is the attractive force? We have to find out the electric field and multiply q with that, so that these two will be exactly equal. Then only these forces will not experience any force. I'll repeat it. The key point is that the repulsive force on each other has to be exactly equal to the force exerted by the electric field produced on the surface of the smallest sphere of radius a. So that is the key point. Now I'll go with that. So let us consider this is having capital radius r, and this is, so there are two opposite, diametrically opposite points, a and b. These are a and b, diametrically opposite points. Okay, so here minus q charges or capital Q charges are there, a and b. Now what I'll do, if I just consider let us consider a thin cell, like not thin cell, a cell of radius r and having thickness this one. Okay, having thickness, so this is up to here r, this is suppose dr, so it has thickness dr. Okay, suppose thickness dr. If I consider a cell, spherical cell, then what is the charge contained in the cell? What is the charge contained in the cell? We can find out rho r into the volume of this cell. Since it is a solid sphere, so the cell also will have a volume. So what is the volume of the cell? So let me write, this is kr, sorry, k into r, and what is the volume? Volume is actually 4 pi r square and dr, because it is a spherical cell. 4 pi r square and dr. Okay, so that is a elemental charge on this elemental cell. Now if you want to find out the total charge on this whole sphere, that is 2q already given, then we have to just do the integration. So this will go from 0 to capital R. Okay, if we do the integration part, then we can find out what is the total charge, and that total charge is given as 2q. Okay, let us just go with this. So 4 pi and k, let it be there, and this is r cube dr, 0 to capital R. So it will obviously be pi k r to the power 4. Okay, r to the power 4. So if it is pi k r to the power 4, then what is this k? This k is going to give you the constant which was along with the density part. So this was missing actually. Q by pi. So 2q by pi r to the power 4. So we have got this constant. This is not 1 by 4 pi epsilon naught. This is actually coming from this rho r. We know rho r is equal to k into r. We don't know this constant. So we are able to now find out what is this constant. So that is 2q by pi r to the power 4. You might be thinking why this is needed. We'll show you how it is necessary. Now look, we are just trying to calculate the electric field on the surface of this, because the electric field will be symmetric everywhere the magnitude of the electric field will be the same. Okay, so we can just use Gauss's law from here. See, Gauss's law state EDS, E into area, right? EDS, integration EDS is equal to total charge held by this surface. So total charge actually Q enclosed by epsilon naught. Okay, this is the since it is actually, see, on the right hand side, see this area, what we can do, we can write, this is a cell, right? We can again consider that the same thing. So 4 pi, so this will give you 4 pi, sorry, this is a sphere, 4 pi a square. So this will give you 4 pi a square, the area. So E into E is constant everywhere by the symmetry, spherical symmetry. So E into 4 pi a square. So the left hand side is okay with me. But what about, I'm just erasing this part. What about this total charge enclosed by the sphere? So let me write this enclosed charge. See, again we have to write rho dv, rho into dv, and do the integration 0 to a. Okay, so here we get 4 pi a square epsilon naught this, and look here it will be again 4 pi a square, or 4 pi r square, you write 4 pi r square into dr into kr. Kr is the density. So from here what we get, 4 pi k divided by 4 pi a square, and integration will be on 0 to a, this is r cube dr. So from here, look, what we get. So 4 pi goes up here, k by a square into, this is a to the power 4 by 4. So this will give you ultimately k by 4 a square. This k is actually coming from the density part, and which we have the value with this. So we'll put the value from there. So 2q by pi r to the power 4, and here anyway there was a 4, here 4, and here this is a square. So 2 goes up, so 2 pi. So you will get actually electric field to be q by 2 pi, and here there was an epsilon naught obviously. So 2 pi epsilon naught a to the power x square by r to the power 4. So this is how we get actually, see, the electric field to be, we can write just 2q, this is not q square, this is okay, let us write as 2q itself, 2q divided by 4 pi epsilon naught into a square by r to the power 4. So what we have got, electric field on the surface everywhere, the magnitude is same. So if you want to calculate the force due to the electric field Fe, so that will be, for since the charges are same on both the point minus q and minus q, so we can write the electric field q into E, and I'm just taking the magnitude. So this q is capital Q and E is this part. So you get actually 2q square by 4 pi epsilon naught a square by r to the power 4. Okay, so this is the electric force, or the force due to the electric field produced on the surface of the sphere of radius a. Okay, so what are the things we have got here? We have got the force due to the electric field produced on the surface of the sphere of radius a. So that force we have got, that is attractive force, since this electric field is always acting outward, and this are pushed into the towards the center. So electric field will be like this, and force on this will be towards the center for both of them. Okay, and this force must be exactly equal to the repulsive force. Repulsive force we have already, I'm just writing here. So this Fe must be, this Fe suffix is due to electric field. Fe must be equal to the repulsive force, that is q square by 4 pi epsilon naught a square. Sorry, this a square, not a square, this is a distance 2a, so 2a square means, okay, let me write 2a whole square. Okay, and left hand side we have got already 2q square by 4 pi epsilon naught r to the power 4, and this is a square. So if we just equate them and solve for a, so this will give you 4a square. Okay, so if we solve for this, see 4 pi 4 pi 4 pi epsilon naught, both are going off from both sides, q square going off from both sides, and see it will be actually a to the power 4, a to the power 4, and this is 8 e to the power 4 is equal to r to the power 4. Okay, so this is what we get. So if we get a to the power 4, 8 a to the power 4 is equal to r to the power 4. So a to the power 4 will be r to the power 4 by 8, and hence a will be r by r to the power 1 4. Okay, so this actually you can write as r to the power 8 to the power 1 4 into capital R. So there is an option, you can see the first option itself, this is the answer here. Okay, so we can see these problems, even though these are actually, this is 2019 JEE mains question, 2019 JEE mains question. Okay, mains question. So these are actually a little bit lengthy, and even the previous one also, this is very important problem. When you have a dielectric constant having variable thickness, then you can do the integration, and then finally you can calculate the capacitance. Okay, so I'll stop it here for today. Thank you for your patience, and we'll meet again on Wednesday. Okay, so bye for today.